Hi guys, welcome to today's video. This one's going to be an introduction to electronic configurations. Now normally when we talk about electronic configurations, we use what's called subshell notation. So that means we're using s, p, d and f orbitals. I've got another video on that. This one firstly is just to kind of introduce to you the concept of electron shells and how many electrons are in there. And then after this video, if you want to go to the next step, I suggest you then watch the video on electron configurations that will go into those subshells and how we do the normal electron configurations. So what I want to introduce to you first is the concept of how many electrons a shell can hold. So as you know, there's a nucleus in the middle of an atom, and then there are electron shells around that nucleus. Now each electron shell can hold a certain number of electrons, and we use what's called the 2n2 rule to work out how many they can hold. So the 2n2 rule simply means that we take n as the shell number, we square that, and then we double it. Okay? So if we're looking over here and we consider the shell, all right, and then the number of electrons it can hold, okay, in the first shell, 1 squared is 1, 2 times 1 is 2. So the first shell can only ever hold 2 electrons. And that's no matter what atom it is, that's always the same. The second shell, 2 squared is 4, 2 times 4 is 8. So the second shell can hold a maximum of 8 electrons. The third shell, 3 squared is 9, 2 times 9 is 18. So we can hold 18. And you can keep going with this. The fourth shell can hold 32, and so on and so on. So that's important for us to know, because when we've got that information, we can use that along with the position of an element in the periodic table to work out its electron configuration. Now, it's really important when you're looking at an element that you know how to work out what group it is in, and also to work out what period it is in. So the groups are the up and down columns, so you can work it out, and the group tells us how many electrons in the outer shell, or the valence shell. So the valence shell or the outer shell, right, that can generally hold a maximum of 8 electrons. And the group number tells us how many are in that. And that's really important, and I'll show you why in a minute. The period, this tells us how many electron shells we have. Alright, so give an example of something. Okay, so let's look at calcium. Okay, atomic number of 20. Alright, it is in group 2 on the periodic table, and it's in period 4. So straight away from looking at that, we can tell that it has 4 shells, 4 electron shells, and it has 2 electrons in the outer shell. That's what the group number tells us. Now this doesn't always work out that nicely. When you're looking at things like transition metals, for example, transition metals don't really fall within one of the 8 groups. They're in the middle, and so that doesn't always work out very nicely for you. But most of the time, the rule you can take for transition metals is that they have 2 electrons in their outer shell. Okay? Sometimes they might have 3, sometimes they might have 1, and it depends on their oxidation state. But general rule, if you want to try and work out the electron configuration for a transition metal, go with 2 in the outer shell. So I'm going to show you how we take this sort of information to write the electron configuration for a calcium. Alright, so when we looked at calcium, we looked at that it was in group 2. And that told us that there were 2 electrons in the outer shell. Okay? We also saw that it was in period 4, which told us that there were 4 electron shells in total. So it's really easy to work out the general electron configuration for a calcium atom if we use our 2n2 table. Okay? Now, the atomic number of calcium, atomic number, was 20. So we're trying to get the number of electrons in our shells to equal 20. Right? So in a neutrally charged atom, the number of electrons will equal the number of protons, and we know the number of protons because of the atomic number. So what we're going to do is we're going to start going through shells and we're going to fill them up. Alright, so the first shell we know can hold a maximum of 2 electrons. Okay? The second shell can hold a maximum of 8 electrons. Alright? Now if we add 2 and 8 together, we get to 10, and we know all we need is another 10. So if we wrote 2, 8, 10 as the electron configuration and we got our 20 electrons, right, we filled up the number of electrons. The problem is we haven't met 4 electron shells, so we're still missing a shell, and we haven't got 2 electrons in our outer shell. So 2, 8, 10 is not going to be correct. So what we need to do is we need to know that we've got 2 electrons in the 4th shell, and we can work out how many now fit inside this 3rd shell. 2 plus 8 is 10, plus 2 is 12. To get to 20, we must have 8 there. So 2, 8, 8, 2 is the electron configuration for a calcium atom. Now this 3rd shell, the maximum it can hold is 18, but it doesn't have to hold all 18. Okay, that's just the maximum it can go to. So that's what you need to keep in mind. That's why knowing the period and the group numbers are really important, because that allows you to work out how many shells you've got, how many electrons are in the outer shell. So let's look at another one. So what I'm going to look at this time is sulfur, which is a non-metal. So sulfur has an atomic number of 16. Okay, so if you look at it on the periodic table, you will see that it is in group 6. Whoops, good thing I can spell. So it's in group 6, okay, and it's in period 3. So what that tells us is that it has 3 electron shells, and there are 6 electrons in that outer shell. So what we do is we go through again, filling up our electron shells, and we want to try and equal 16 as a number here. So the first shell is going to be 2, the second shell can hold 8. This time we only need to get to 3 shells. 2 plus 8 is 10. We need 6 more to get to 16, and it's in group 6, so yes, it's going to have 6 in the outer shell. Okay, so 2, 8, 6 is what we use for sulfur. So let's look at another one. Let's look at rubidium. So rubidium is Rb, atomic number is 37. Okay, it's in group 1, which tells us there's 1 electron in the outer shell, and it's in period 5, which tells us that there are 5 electron shells. So what we're going to do is we're going to go through, as we go through the shells, we're going to try and get it to equal 37 with 5 electron shells and 2 in the outer shell. So the first shell holds 2, the next shell holds 8, the next shell can hold 18. If we go through all of those, 2, 8, 18, that adds us up to 28. We know that the final shell is going to have 1 electron in it, so that gets us to 29. Then 37 take 29 gives us 8. Now there's a couple of interesting things that you can use with these electron configurations. When you're trying to work out the charge on an atom, the electron configuration gives you some indication as to why it has the charge that it does. So rubidium here in group 1, what it wants to do is to lose that outer, it's 1 electron here, this one on the end, to get a full outer shell of 8 underneath. So that's why rubidium has a 1 plus charge. Sulfur over here wants to gain 2 electrons so that it becomes 2, 8, 8, again having a full outer shell of 8 electrons. I'm going to cover that in another video, but for the moment, hopefully this has been a good introduction, just a real basics of how you get electron configurations. What I suggest you do next is start looking at the following video, which I'll put the link down below, which talks about how you go into electron configurations using subshell notation, so S, P, D and F orbitals, which is the way that we always generally refer to electron configurations in chemistry. Hope this has been helpful. As always, if you've got any questions, just ask. Thanks guys.